Welcome, everybody. Thank you for joining us today for this Hidden Layer webinar. We're here to talk about securing AI in 2026. Our goal is to offer some insights into what we've seen and what you can use moving forward. We're going to have a discussion with some practical considerations on how you should think about where you are or your AI security journey moving forward. We also have a form where you can submit questions. We'll try to answer as many as we can at the end. And before we get started, I want to introduce myself. I'm Mike Brushansky. I'm the Chief Product Officer at HiddenLayer. And with me, I have two distinguished gentlemen. First and foremost, I have Josh Lemos with me. Josh is currently the CISO of GitLab, former CISO of Square. And Josh has a wealth of experience in AI and security as a practitioner and a researcher. Thank you, Josh, for joining us. Also with me is Jacob. Jacob is the Chief Technology Officer here at HiddenLayer. He's previously worked as an architect at Salesforce and Agari. Jacob, thank you very much. Well, let's kind of get started with looking back. I know we're already almost through January in 2026, but if we look back at 2025, I think it's pretty easy to say that it was the year of AI. It's almost a cliche at this point to say it was everything and everywhere. And depending on who you ask, it's either the cause of or solution to all of our problems. Maybe starting with you, Josh, from like a CISO practitioner perspective, like what developments do you see with AI and specifically AI security over the past year?
Yeah, a lot has changed over the last year, Mike. I think that we don't have a great definition or category of AI security yet. So I think that we'll parse through some of that today. What people call AI security can range from protecting models to ML ops to, generally enterprise AI and applied ML, like in the cases of things like, Copilot or Glean or, pick your enterprise AI solution. But one of the things that I have noticed a shift in the last year, 18 months has been, if you would have asked me from a security perspective, do we have an advantage on offense or defense? It felt very clearly defense had an advantage a year ago, a year and a half ago. I think that has shifted. We've seen agentic attack chains. While both offensive and defense have progressed, I feel the power balance has shifted pretty strongly towards offensive agentic use cases. And then everyone is building AI features into their products. And so if you are a builder of software of any kind, you're building something with an API plus a model and figuring out how to monetize that in your product today.
Yeah, that 100% agree with you, Josh. That totally makes sense. I think we've seen at HiddenLayer when we talk to various customers, we're still seeing widely varied degrees of where people are in their AI journey with maturity. But I think you call out exactly some key points. Like the definition is pretty loose, but like people are starting to bring these things into production all over the place now. And I think that's definitely a shift that we've seen over the past year. I don't know, Jacob, maybe what do you think we've seen with some of our customers? What do you think is important to them, as they come to us looking for help with them in AI security?
Yeah, I think, when we talk to organizations, a year or 2 years ago, a lot of them were, we talked to the early adopters. They're trying to get ahead of security. They knew they had a bunch of different AI initiatives. They knew they had some risk or presumed they had risk, but wanted to understand more. And we'd work with groups. We'd work with innovation groups. We'd work with labs groups. But now we're working with product engineering teams and security teams with deployed software. And often they're coming to us like, hey, we want to deploy this next week. We want to double check whether it's secure or not. Or hey, we deployed this 6 months ago, but now we're trying to sell it to enterprises that want us to prove to them that we have a secure solution, whether that's going through like an ISO 42001 process, whether that's the endless array of enterprise security questionnaires that people that build software and sell to enterprises have to fill out. How do you have some provable controls? And that's where we've come in, and we're, like you said, we're working with them at different stages. Sometimes it's how do we secure the supply chain. Sometimes it's how do we ensure the runtime of the applications is correct. But We work with them, and everybody. I don't think we worked with a single organization that says, "Hey, we figured it out." There's always plenty of issues.
Yeah, definitely true, and that's okay, right? Like we understand that, like we said, we've seen some maturity. This is a new space. It has a lot of similarities in terms of AI security, in terms of similarities to previous sort of security techniques. But again, great call out by Josh. Is like the definition is sort of loose. People know that there's a problem, but what we've seen with our customers is they can't really put their finger on how to solve it. So I guess Josh Lemos, looking to you as the resident CISO expert here, looking forward to 2026, considering people are at various phases in their journey, what advice can you offer to maybe a new CISO or a CISO who just started their AI journey? Like, where would you start, and how do you start to conceptualize and think about the problem of AI security and the threat vector it brings?
Well, first, Mike, be careful throwing the word expert around. I would never self-apply that, and anyone who would, you should be really cautious of, especially
You're a humble guy, Josh.
all
You're a
those
humble guy.
charlatans out there. Um,
Yeah.
when I think about taking on any new problem and sort of bringing order to the chaos, you have to view it through a couple of different lenses. And one of the frameworks I find valuable is to think about your usage discovery problem. Where are you using um, AI and ML throughout your organization? Do you have a data science team? Are you building models? Do you have that enterprise IT AI usage? Are you building agentic software products? From there, what degree of observability do you have? Are your existing tools and capabilities providing observability? If not, where are those gaps? How to think about that. From observability, you can get to your controls to manage and sort of think about what ways can you interdict bad things from happening within your AI ML environment. And then finally, you get to policy and governance. Like, how do we want to apply those controls to what environments, and to what degree do we need to have control over them? We have prior existing art in this space. If you think about product security teams, they've been working on frameworks on how to reason about building software for a very long time. And a lot of those are reusable mechanics for building models and operationalizing AI and machine learning. At GitLab, our VP of product security, Julie Davila, developed a framework called the Software Factory Security Framework, and it has some core principles in it. There are some core stewardship principles you have for running a software factory, essentially. You have supply chain, you have your processes, you have your runtime, you have your third party, and then you have your sort of continuous learning, continuous advancement. All of those are useful in terms of how you define your program for managing ML security, AI security at scale. And if you think about those considerations, you can sort of break that down into technical and product gaps and begin to reason about where you need to apply your controls. Every company is going to be different depending on those use cases that you discover in that early period, and then applying that over time will accrete those security benefits. I think that's sort of like the high level of how I'd approach that.
I think that's spot on. I love the way you consider it like a software factory. I think one of the changes that we've seen, and I think you're sort of alluding to here, is back in the day, it required a data scientist to do ML or to have machine learning or AI. Now, AI is everywhere, and you need to think about it as part of the process and not as a one time, let's go figure it out. Let's build it into your kind of overall considerations. I think that's a great way to frame it up. Sounds kind of like pretty typical security processes. Maybe Jacob, like, what do you think the got yous are there that you see? There obviously AI brings its own slant and its own view to it. Where do you see this? What do you think about organizations that are able to do this successfully that we've seen?
Yeah. Well, so let's touch on the first part of that of discovery. Mm-hmm. So last week, just as an anecdote, I was out visiting a large HR company, and one of the things we started when we engaged with them is they knew they had a lot of usage. The security team was aware of a few things, but they had instead of it being a few dozen uses of ML and AI throughout their systems, they actually had thousands, and that included not just well-known products that interface with customers, but a lot of back office functions, other types of internal automation workflows that are increasingly being adopted all over the place. We can actually show an example in our product of the discovery, if we can switch over to that, Ryan, of our platform, where one of the things that we do when we first engage with customers is just to instrument all the different environments that they have. Oh my goodness, we log out. If you log in too soon, we have security policies to make sure.
Proper security tool right there, Jacob.
Yeah, to make sure you hung up. Just a second. Let me switch this to the appropriate account. So we just want to make sure that we're connected to enough of the environments that we can actually identify your security risk, and then that allows us to assess and scan those models, scan those applications, and see what sort of posture or threat you want to do. But you can't do that if you can't actually see it. Got it set up. Let me pull back to share the screen. Here we are. So here's an example of one of our test environments. But you can see we have a lot of different AI assets, not just models, but also endpoints, agents, things that we're looking at, across a variety of different providers, and see what they are. And also we assess them against our internal compliance policies in their different environments to see whether they meet the relevant controls with the rest of the system. So I think that's the basis of a starting point. You can't actually secure or control what you don't actually know exists. So Mike, I'll turn back to you. We'll talk about some of the other risks that we can mitigate.
Yeah, I think thanks for the demo, Jacob. Like, very common question our customers could bring to us is, hey, what can we do with our AI? Where is it? I think observability is the first step to that. And yearly we produce what we call our threat report. And in that threat report, we compile a bunch of information from surveying our customers. And one of the things that stood out to us this year is that 76% of all the customers we surveyed, or organizations we surveyed, responded that shadow AI is an issue for them at some level. Our focus here at HiddenLayer, of course, is on the applications that are being developed within your organizations as part of your software factory, as Josh mentioned, and we can help sort of illuminate it. And again, it's a good practical first step. A great suggestion by Josh. So I think if I think about your framework, we found our AI. What are your next steps, do you think, for security orgs on what they need to do in terms of evaluating their security and their security posture? Josh, what do you think?
Yeah, I think that if we consider the use of AI and like what constraints you may have from like a regulatory compliance or privacy perspective, you can kind of reason about what to do once you've found your AI usage across your environment. In security, and especially product security, you have a concept of paved roads. I think that's really applicable to what we're orienting ourselves towards in a AI-centric world, right? We're figuring out what are secure design patterns that we want to adopt in our enterprise, and what do we want to monitor for, and how do we want to protect against those security anti-patterns. Going back to observability, it is model observability, but it's more than that. We have MCP servers. You need to know if you can identify MCP servers or models running on endpoints. And then think about, from a governance perspective, do you have provenance over those artifacts as well? So when you think about software supply chain security, you also have ML supply chain security. So you're going to have model provenance. Is this a random model? Was this something built in-house? Was this something downloaded off Hugging Face? Where did this come from? And is that something you want to run in your environment? Has it gone through sort of the requisite checks that you have, and is it compliant with your privacy policies and your regulatory oversight such that you can use those? So that's how I start to think about and reason about that once you're discovering model usage and AI usage across your enterprise and your fleet.
Yeah, Josh,
Totally.
I think you touched
Go ahead,
on
Jeff.
two big points I think that we've observed over the past year, which is when we're working with enterprises, um, a lot of them have moved to more of a consolidated, centralized AI infrastructure model. So that there's the set of vetted models, that golden pave path that has been approved by the organization that people can access through common infrastructure and manages common observability, maybe reverse billing, and also the security controls to vet that activity. But even as organizations have built that up for more of like the chatbot RAG kind of model where you're interacting with an LLM directly, it's falling short as everyone's rapidly adopting agentic type solutions where you have frameworks that are calling out to all sorts of different APIs and MCPs and ADOAs and different tools. And so even as the LLM access becomes centralized and controlled, the potential impact on the organization involves a lot more behavior and surface area that you got to analyze.
Yeah, absolutely. I think that's another thing, we keep hearing again is like the governance aspect to it. AI, everybody's concerned about data, where the data lives, and bringing that into the conversation in a continuous manner for addressing issues where you can't follow those paved roads. I mean, a lot of times AI is really good as a force multiplier, and we see our customers, I think, quite often, what is the exception process and how do I make that exception process move efficiently is an area where I think we've seen our customers sort of invest or be interested in. Again, very practical. Like in terms, Jacob, maybe to you, what do you think is important to our customers specifically, and how have we realized, or our steps that we've taken to sort of realize it in our product? There.
Yeah. So, I mean, I think when we look at, first you discover sort of the models and the environments, but then we want to assess the supply chain of those. And, the things that they find valuable for that is first, where did those things come from? They came into your environment in some way. Josh mentioned this. Did someone just randomly download something that's, open weight? Are they using models from one of your, cloud vendors that have already been vetted that way? From those models, there's security concerns of how the model's been backdoored or otherwise manipulated, but there's also other types of compliance and risk concerns. And this gets to the provenance kind of questions. Did it, do you have a stance potentially as American and Western company? You don't want models coming from Chinese labs. That's a thing that we hear a lot amongst our customer base, and that's not always obvious, especially if your organization maybe fine tune one of these models and you're looking at the end result of a model that doesn't match the SHAs and other things that an organization might be looking at to see where this artifact is coming from. So a deeper understanding of where this model originated from and how that applies to your own policies, and ensuring that you can integrate that at different points in your workflow. Like how can you ensure, the classic term for DevSecOps is shift left. How do you have your developers that are, not data scientists necessarily, that are pulling these in, can identify there's a potential organizational issue and choose a different model or a different approach early on in the process. And then how can the security organization get visibility into that across the entire enterprise? And so we see that kind of visibility and observability being of a lot of value to an organization trying to get a handle on the rapid adoption.
Yeah, I think this integration with other systems, I think being part of the ecosystem is always important. Like playing into some of the things that we've added in our product that people are interested in is like integrations through ticketing systems and sharing governance information with governance. I don't think it makes sense. And Josh, maybe I could ask you this. Like, it doesn't make sense to invest into another AI specific governance tool, but something that can feed into that with information that is meaningful and you can kind of use to help check the boxes and confirm that you're doing these things is where our customers seem to be invested. Um, Jacob, is there anything you want to show within our product now that
Yeah, we can jump over. We can
maybe
show an
give a
example of some of our
context? Yeah.
we can show an example of some of our asset scans when we're looking at models or different environments. So I mentioned the discovery. You can go from these, in our system directly to how it relates to other assets, the applications. But if we look at a particular model, we can see what does the scan look like. Are there issues that we want to explore? What are the detections? What did we capture? Is there something like an arbitrary code execution that's occurring as a backdoor within the environment? And so we have the ability to identify that and then tie it back to the reports of where that exists within your environment. Um, So, I think a lot of organizations find that valuable. And you can also tie that, like I said, to the policy in terms of, what is compliant or non-compliant, or however you want to call that within your organization. Map it back to which models are meeting those compliance status, and the specific scans that we see over time. So that gives you a pretty strong baseline of saying at least the underlying models we have in our environment meet our policies. And then, and I think we'll talk about this next. What does that mean at the application level in terms of how those are configured and embedded within agents or chatbots or other types of systems?
Yeah, I think this is something I think other security or existing security vendors don't do quite well or right now. And so the level of introspection that our customers need, at least, is a little bit extra from what they have today, and it has merited a lot of investment in the hidden layer tools, and to provide this level of governance it's not easy to come by. The other option we've seen from our customers has been to apply manual resources to do some of this decomposition of this, or manually go through, and assess for vulnerabilities, and it's just not a scalable sort of thing. So, great. Okay, so we're doing great. I think we've got discover our models, do some level of supply chain assessment, create those paved roads, have some perspective on governance. Font of expertise here, Josh. We saw similar information on our threat report, where we heard from the people we surveyed that 78% of all of those surveyed view embedded third-party AI models is critical to business success. From there, I think Jacob kind of alluded to the next step. All right, we got our models, we've assessed them. Now we're getting ready to develop and deploy an application. What's your next suggestion about how to approach AI security now that we've discovered and evaluated the risk and the governance for it?
Yeah, Mike, I think that it's no secret that the frontier model providers are beginning to really take hold of that 78%. And they are enabling the vast majority of customers to build on top of their existing software stacks. And we have to sort of think carefully about how those security boundaries may have changed. This is the part at which we get into more of like the runtime considerations of security. So not necessarily a hidden layer concern or product offering, but how you think about identity within this context is really important. The current OAuth standards don't extend well enough into this space to give agents their own pure identity. So we need to really think about, do you do composite identity? Do you apply identity concepts to a team, right, or an individual? One of the things that we do at GitLab is we essentially associate a developer with the agentic action. And we think about what actions that agent can take on behalf of the developer. And so you have a lot of complexity added into your role-based access control model at runtime to think about what actions that agent can take. Are they confined? So as you're building skills in your runtime, you want to think about what those skills can do and how they can do them and how sort of safe they are, and then monitor those for drift and make sure that those skills and those agents are sort of behaving over time. So again, it ties back to observability, but it's sort of runtime observability at this point now.
Yeah, I think that totally makes sense. I think obviously, we don't consider identity at hidden layer, but that's certainly a valuable thing that our customers need to think about. When in terms of the runtime aspect, it's a very common request that we have. We have customers that come to us and say, "Hey, we're getting ready to deploy something. How will this behave?" And it's tricky due to the nature of the technology, the fact that it's all sort of non-deterministic. And we have to understand kind of what remediation options that you need to apply, whether it's through other systems or just kind of understanding the behavior. And it can be done obviously with red teaming services to kind of get to that level, but we offer some kind of automated system or automated attack simulation systems that we use with our customers to really test their application. What do you think, Jacob, maybe about how we see our customers approach this and how they can address sort of what Josh brought up.
Yeah. Well, I think one of the interesting things about identity is that when you're executing some sort of AI application or agentic application, there's actually two other ride-alongs with you. You got whatever inherent training and actions are in the LM itself that it might want to perform in addition to the user's intent, and you also got whatever context has been injected in there by third parties. So if you're pulling in data from the public internet, you're pulling in data from your own databases, whatever that might be, that also adds additional instructions. So while you can limit, and you should, as a best practice, limit the activity of what additional APIs or MCPs or whatever it might be that system can perform to some scope thing for that user, whether or not it should perform those actions that it's allowed to do is not just influenced by your user instructions. It's influenced by everything else you're pulling into the context. And so that presents a lot of additional risk. And that's one of the things that we try to assess. We do that with our attack simulation. We also do that with our runtime security, observing as it's happening, whether or not we see something that's potentially unintended. We'll show that in a minute. But one of the things I think that's an interesting trend over the past year that we've seen with the latest frontier models is that a lot of them actually have been tuned in such a way that they're sort of more permissive in that the model as a whole will let you do different things. It's not as locked down and highly fine-tuned as earlier generations models. If you can only produce content like this, or it's only using this particular tone, or whatever that might be. And instead, they're much more sensitive to what you put in the system prompts and the instruction hierarchies in terms of the alignment, which means you also got to make sure you lock those down quite a bit to actually ensure that you're specifying the behavior as correctly and narrowly as possible. So that's another best practice to consider. Ryan, can we jump over to the demo, please? Well, so we have our attack simulation system where I'll show you an example of a test I ran earlier today, or yesterday rather. And you can see that we have lots of reports of the different techniques that we ran through. This itself is an agentic system that's dynamically messing around with the different interactions. I could see what different techniques it was using. I can look through and see the actual interactions and what the responses are. In this case, this is like a social manipulation attack where it's initially refusing to do it, but then we try to confuse it to say, no, we really need to do it anyway, and are able to get it to return the payload of whatever activity it was hiding and not something it should have shared. But because of the escalation of thinking that we're in a more secure operational environment, and it doesn't matter that it's aligned to do this. We are now in this crisis mode. It has to give us the data. It didn't anyway. Lots of different ways to mitigate that. One is our runtime controls, but another is also our system prompt hardening that we rolled in this, which you can say, okay, well, here's a very basic kind of system prompt that is configured along with the system that we tested. But you can also then refine this to add a much deeper set of controls to limit what it can actually do. And then we can retest it to see whether it actually is limiting itself to not perform those actions. So that still has edge cases where that might happen, and that's why you still need some runtime security. But if you can harden your prompts, you reduce the surface area quite a bit. So you need to do those evaluations systematically before production and continuously as your system changes and evolves to have some assurance that it's working correctly.
Yeah, I think that was a very practical thing that we discovered. That I think through our CTFs, some of the CTF work we did is like one of the best things you can do is harden your system prompt. I think the other thing that's kind of an interesting observation with that is it's not all created equal. So depending on the foundation model that you're using or frontier model that you're using, the hardening techniques that you need to use for your system prompt can vary kind of dramatically. And so that's where we've seen some success in combination in our simulated area, where you can test the system prompt, harden your system prompt, test it with this red teaming, and see sort of the effect on your security posture or what you're susceptible to. I thought that was kind of interesting.
Yeah. One of the cool things with, I think one of the things we rolled out that we've seen some really strong adoption with pretty quickly is the fact that because the models our customers are using are largely the standard models, although we can connect to the real models as well, we can simulate an application using different system prompts and test that at scale without having to glue it up directly to their application with whatever custom APIs and things that the security team would have to go back to their development teams to get them to add that. And they probably should as part of their integration testing process and probably will, but it's hard to do that at scale with hundreds of different development teams. So being able to simulate that, identify the risks, identify specific fixes, get those back to your engineering teams reduces that cycle time. And so we found that to be pretty valuable.
What do you think, Jacob? Can you talk a little bit about, you know, kind of continuous testing, sort of like, okay, we have this cool AI attacker agent that can illuminate vulnerabilities, but we've seen, I think, from our customers that, like, you can make a small change and it can dramatically change the outcome, or change the result of your application. Like, what have we done along those lines to help with that?
Yeah, I mean, we have customers that are integrating into the CI/CD process, and also periodic synthetic testing going into their production environments continuously.
Mhm.
Also, there's a trade-off between how much testing you actually do. Like even the same scenarios, you got these sort of random stochastic results. So a single test of the same thing maybe produce different responses. Like you actually have to look at if I run the same attack 100 times and 40 of them succeed, that's sort of an interesting data point. If you just ran it once, though, it's almost like a coin flip. So you actually need some of that breadth of coverage. That's an important thing to keep in mind as you're testing these systems. But yeah, you need to continually do it. Another thing that introduces stuff in the context, like we mentioned, is like adding additional tools to your system. Now add something, adding additional data from different databases and things like that is going to influence the context window, so it can cause it to perform different things. So you need to be continually monitoring for these things, or else because you don't have this sort of static deterministic behavior that was determined at build time.
That totally makes sense. So sounds like life's kind of tough for a CISO, Josh. Like we've kind of learned AI is everywhere and it's hard to find, and then we have to assess it in a different way, and then testing is difficult in understanding, how applications are going to perform under world tests is sort of difficult. One of the things we heard from our threat report again was, only 69% of the people that we surveyed even know if they've experienced an AI security breach in the past 12 months. People are sort of uncertain about compromises. What is your next suggestion about what we should do, and how you're thinking in your big CISO brain about what we need to apply to this in order to secure our applications when they're fielded?
Yeah, I think that even like the term AI security breach like lacks definition. Like what
Yeah.
does that mean? Does that mean your models were attacked? Does that mean that like you leaked data as a result of using like a frontier model? All of those things are sort of difficult to quantify, and you get into the proving a negative problem. Sure, like do you know if something happened? Only if you had some way or some signal or detection on it. And so when you think about um, putting things into production, I think about, do you have sort of audit, and are you emitting the right events to know what normal looks like? So if you have sort of like a normal performance curve and a normal sort of normalized expectation of a service, can you collect signals when that service deviates from those normal patterns? Um, in an AI sense, that could mean many different things. That could mean that the service was designed to call a tool which calls two services. Well, if that tool starts calling like 15 other services, or those services create second, third order calls, can you detect that? Or if you are an application that is only serving customers in French, and all of a sudden you're getting inputs into the model that are in, Klingon or Swahili or something, do you then at that point decide that like this is probably not normative for the application, and generate security events on the back of that. That's sort of how I begin to think about reasoning about what happens in production. Also, the actions that are taken. You have a series of software applications that are operating on CRUD operations. Do those follow sort of normative patterns, and can you figure out deviations through your observability stack? Those are really important considerations when you want to apply governance across your production AI.
Yeah, I think that totally makes sense. We've seen customers try to solve that problem in a couple of different ways. Like, one that's using existing protections or guardrails and systems that don't really sort of answer it because there's so much variability in that. There's a lot of customization that's needed, or they take kind of the extreme opposite perspective, is they build their own guardrails, and neither of those tend to work out that great. And I think you're right. There's a good good crossroads of observability, and understanding what is right and what's right within a certain context and not right within the others. And again, with the wide availability, or the wide breadth of responses that these generative AI applications can generate, makes that particularly difficult, as you highlight with the language problem. And maybe Jacob, like, why do you think this is, and what do you think? What's our approach to that, and where do you think we've seen customers, regardless of where they're coming from, solve the problems that Josh highlighted, well or poorly, based on their
Yeah. Well, I think
approach?
it's a hard problem, and it's
Yeah.
one that the existing tools across the board, including ours. I mean, we're working toward making this a lot better right now. Don't have great coverage, because I think you're addressing two different problems that overlap.
Yeah.
So one is basically a distributed tracing problem, and there's plenty of distributed tracing tools that application teams use. I think those are underutilized by security teams. But to understand the interactions between things, security teams are often doing reconstruction after the fact and SIMs of pivots to figure out what happened. But application teams are using those to more like assess performance bottlenecks along those lines. But that's like absolutely required in any sort of agentic workflow where you have multiple chains of activity between systems, between agents, between tools, and different backend APIs and cascades of microservices. So you have that problem, but then you also have that problem which those tools completely miss, which is any sort of semantic assessment of the payloads going through them. So you can see the connections of a call from call A to call B, but a lot of agentic systems, that it could go through a user input to query some database, to call some API. Maybe that looks the same, but the malicious version of that and the benign version of that look the same at the tracing level, but don't look the same at the content level, because you've asked it to cause something different, or vice versa. Maybe activity of doing 100 different tool calls that you didn't see before is also indicative of something wrong. So how do you actually assess those threats and see it? So we see that with customers. We're looking at how do we get that sort of deep content inspection, and then how do we tie that to the different request chains, whether that's back to someone's SIM that we integrate with most commonly for security groups, or into those sort of distributed tracing systems. So I think that's what we spend a lot of our time on. It's also where we're working, probably our biggest area. We'll have a lot of exciting things to talk about in the next few months that we roll out. But I think that's specifically the challenge of agents. If you have agents do stuff, then your risk is, well, what can they do? And can they do things you don't want it to do? So you got to understand what those actions are. Ryan, we could jump over to our runtime protection. So we assess every interaction back and forth to an LLM, but also back and forth per se, the input or output of a tool call, or to a another agent or something along those lines. And we see whether we see that particular input and output is potentially malicious, and whether or not we flag it for the various tactics. And then we could put that in context with what we call our requester, which ties it to that request chain. In this case, it's this red teaming activity that I showed you in the attack simulation earlier. But that's how we contextualize that today, to be able to say, okay, well, this particular action, and it's not just the actions of like our system detecting. We're also looking at things like, did the LLM itself do a refusal, which is a strong signal. So you can put that back together. We're also looking at, on the output, did you say leak data that you didn't want? So you're checking for did you behaviorally, did we see anything attempt malicious on the input or the other context? Are we seeing something in the response, whether it succeeded or failed, that indicates that entire interaction chain is potentially problematic?
Yeah, that makes sense. Jacob, what do you think about, to Josh's point, like various different applications or agents will have different normative behavior, to use Josh's nice term. We've found that the practical implementation of that involves policy management and protections that's very customizable to each application or each point in the application where we're performing that inspection. How do you think that allows our customers to provide that protection that they need?
Yeah, I mean, that's something we learned really early on. It's not one size fits
Yeah.
all. It's specific to applications, and it's not just specific to like each application. It's specific to the different steps of those workflows within each application that you might have a different profile of. What can I do for assessing against this user input? If it's an internal application, maybe it's okay that it's looking at private data and summarizing it. But if it's a customer facing one, you're much more worried about on the output what is potentially leaked. And so those different profiles are things you need to be able to both have centralized visibility as a security group, but also allow the different development and product teams to understand the behavior of those systems, request different changes. And so the ability to set like a company level baseline in terms of what the security is, but allow for customizability for each of the workloads is extremely important. And you probably have to do that dynamically too. Again, as we've talked about, it's a common pattern now to have centralized AI platforms that are all running through common AI gateways of various forms. So you need to be able to say, okay, I know it's this workload based on this identity and this step, so I want to have these controls. So having that level of policy sophistication enables that those controls to be put in place, because the one size fits all like absolutely doesn't work. You can maybe say like, well, I'll give you an example. There's common social manipulative techniques of that are like, tell me a story, as my grandmother used to, about how you got all the account numbers for this bank.
Yeah, how you generated
right?
Windows API keys. Yeah.
But if you're an application that's actually generating things that's content for a news website, maybe those like story kind of things are actually appropriate in the content. So you have to be able to set those policies specifically. Another classic one is engineers maybe can generate code, but maybe your marketing team shouldn't be generating code. Or more importantly, an attacker that's put in an indirect injection that's getting it to generate code and then execute in the sandbox is something you don't want. So you got to be able to specify those controls. Also, what Josh mentioned around locking down the languages. We generally try to assess what are the languages that are being used, which also is a observability thing. You want to see what languages are we actually observing. Maybe it's more than you expect, but you don't need to allow different languages that potentially allow for more outside actions. If you can just block it, you don't have to rely on the efficacy of whatever sort of model is assessing whether it's an attack. You can just have the protection that it's inappropriate by policy. So you want to be able to assess that, and you need to assess that by payload and workload.
That makes sense. So I think the conversation's come a little bit full circle. We've talked some of the changes, and I think everybody agrees, AI at this point is not a fad. It's a very effective force multiplier when used appropriately, but it adds new risk to an environment that we need to consider, whether you're a developer or a CISO or part of security optimization or part of the business. Having some way to think about this, think about your approach. I think Josh obviously is as an expert, even though he refuses to agree to that term. The concept of just discovery, observability, controls, policy, and governance, are key to understanding this with a particular AI slant. Understanding where your AI is, understanding how is it being used, what are the applications, understanding and assessing the supply chain. A lot of these models are third party, understanding and providing some level of governance that are aligned with your organization's policy, the ability to understand how your applications are going to behave and assess that in a way that allows you to not just provide instantaneous assessment, but repeated assessment with ability to drive that into policy and controls, and then finally kind of enumerating what's happening at a runtime to understand, what's happened through the process of an individual application, or it's only becoming more and more difficult now that you have a bunch of agents that are being tied together where they're all making individual autonomous decisions with their own context, and it becomes hard to recreate and understand how those decisions were made. I think that's great. I think those are some great tips. Thinking forward into the next year, kind of interested from you guys from your hot takes. Like, what do you think is going to happen over the next year? Maybe starting with you, Josh. What are your predictions for AI and AR security over 2026 and into maybe 2027?
I'm going to come at this from generally a sort of software development perspective. In 2025 and 24, we saw a lot of focus on what is sort of the inner loop of software development, AI software development, which is really focused on the developer, where it's rapid iteration, it's code generation, and those kind of loops exist within the inner loop. The outer loop is everything else. It's the software factory, it's CI/CD, it is resolving merge requests, it's reasoning about dependency management, all of the other things that go into software. We're seeing a lot of acceleration in the outer loop right now with AI. There's a lot of developer frameworks out there for building these agent factories, and on Claude Code and a number of other platforms. So I think that what we're going to see in the security space is a response to those innovations. So to the outer loop innovations, we're going to have to think about how we instrument security when a lot of things that were done deterministically and programmatically in traditional software development are now shifting to these sort of agent factories, if you will, instead of just pure deterministic software factories. So it's an interesting time to be alive, Mike.
Yeah, that it is. I do agree with that, and just the force multiplier is a terrible term, but like the acceleration that it brings to just software development is unbelievable. It is an interesting time to be alive. Jacob, what do you think? What's your hot take going into 2026? What do you think?
I mean, I think it's really the same as Josh's, but just applied to everything. Yeah. So, but when you look at that, I think it's more around full workflows being automated, and so more autonomy occurring within that. So in the development world, like it might be you get the bug report and it auto generates the code to fix it and validates that test works in your test environment and merges that to say the code base. That's a full workflow. Already each of those steps are sort of occurring. Maybe a developer auto generates the fix, but it didn't go necessarily automatically from that like customer bug report. You see the same thing in like business automation of like maybe there's some workflow where someone uploads a PDF with some customer inputted a bunch of stuff into a form, and then someone reviews it and puts it in some backend system and approves a loan or something. Maybe you automated the step of you don't need data entry. You can use a visual LLM to process the PDF and do that. But now we're going to probably move to the step of you don't necessarily need the person reviewing it. It could perform the entire activity from receiving the email, identifying which attachment is relevant in the email, uploading it to some MCP to the application, getting the approval, setting the or denial or something, sending that email back to the user. That entire thing is orchestrated and sent back. So so determining where you want humans in the loop or observability. If I want to have a human observing hordes of hundreds of agents and seeing what's anomalous and how do I correct it. So that's just an extension of the agentic trend just being adopted at greater and greater scale for more and more steps of the workflows.
Yeah, totally makes sense. I agree 100%. And I think we're at the beginning of this AI security journey. I think, as Josh pointed out, that still requires some definition, but I think we'll see that sort of coalesce over the next year or so. That we've even seen, at least from my perspective at HiddenLayer, we've seen our customers come and approach with a little bit more of a mental model, like Josh has, about, hey, these are the things that are important to us for our AI security. And I think that'll sort of coalesce over the next year. We'll identify the charlatans from the folks that really provide some valuable security, and I think it'll be very interesting. With that, I think we have a couple of questions. Before we get to the questions, I want to remind some folks of what we have coming up at Hidden Layer. It's almost RSA time, and that is happening at the end of March. At RSA, we will be releasing our Hidden Layer threat report for 2026. I think it's very interesting. I'm fortunate to have a preview. We talked a little bit about some of the statistics that will be part of that. It's a good perspective. It's always good to see what your peers are thinking, and so that will be released at RSA. Also, I'm the product guy here, or one of the product guys here, so I'm very eager to highlight a new capability or a new product we have coming out directed entirely towards agentic security, and it'll be the next generation of how we understand protecting AI agents, and addressing some of the issues that Josh brought up and Jacob brought up as well. We have a couple of different questions here, Jacob. If we want to start, I think the first one displayed is, how do we find what counts as AI for inventory purposes? Where do we draw the line? Do you count third-party SaaS tools with AI features as part of your AI inventory, or is that a different bucket? Jacob, do you want to start with that one or try to give it a shot?
Yeah, I mean, those definitely count as AI systems that you need to assess their security. We focus primarily for people that are building AI with our platform right now, but that also includes internally deployed systems that might be third-party systems. So for our particular solution right now, it's a mix. But as an organization, you should be assessing all your different SaaS tools, as well as everything that your engineering teams and other groups that are adopting ad hoc AI within your organization are making use of.
Yeah, I put those in 3 different buckets. So I have our model building as one bucket, and those have specific controls and considerations for governance. The second bucket is where we're using frontier models and API calls to external model providers. I think of that and have a set of policies around that as a way to consider our model inventory, or at least our application usage. And then the third bucket, we sort of address that as like enterprise AI usage, and that's reasoned about through our enterprise security program. So all 3, I wouldn't necessarily put the last bucket in our inventory, but it is one that you have to govern as part of your overall security program.
Excellent. Great way to think about it, Josh. And like anything, you're not going to have one security tool to solve everything. I think the question is just making sure that you have capabilities that overlap as much as possible, and that can work together to solve your problems. I think looking at the next question, here's another interesting question. How should organizations be thinking about MCP in the context of their overall AI security strategy? I think that's a great question, something we get a lot. We certainly have a perspective on it. I think, Josh, we were talking the other day, and you said, MCPs and skills makes you feel like a superhero. I think MCPs are very powerful, but they're also very risky in certain situations. Jacob, maybe starting with you, what are your thoughts on MCP and what you can do today to help protect MCPs?
Yeah, I think our take right now for MCPs is that they provide a protocol to allow you to interact with all the different APIs or local applications that the MCP is connecting to. But ultimately, that's connecting into the LLM as context or actions coming out of the LLM that it's asking to perform. And so if you have instrumentation of your AI application, you have instrumentation of your MCP activity, and that's a great place to centralize the controls around what is actually occurring, and everything that we talked about earlier around how do you have understanding what distributed activity is happening and whether or not you have actions occurring that you don't want. You want to have that centralized in place of inspection and introspection to make a decision on whether it's an appropriate action that should occur. So I think that's where I think you should start. But you also, and maybe Josh can speak to this. There's lots of things you need to think about in terms of governance of what MCPs you even want to allow, and how you approach governing what activities can occur rather than did they occur and was it appropriate in the context of that interaction.
Yeah, I think that's right, Jacob. In a large enough enterprise, you have different considerations for MCP, but similar to a platform engineering approach, if you can provide an AI paved road or an AI engineering approach where you provide those MCP servers and they're useful, you de-incentivize people spinning up their own solution in those cases. So it's really being responsive to the needs of the business and being able to govern that properly. And meanwhile, sort of having your endpoint security under control to make sure that you don't have sprawling endpoint servers, having your attack surface management such that you're looking outside in at your environment to see that you're not just exposing a bunch of MCP servers publicly across your managed space. So those are all important considerations and sort of unsolved problems, but teams are responding to the need across the spectrum of companies right now.
Makes sense. All right. Well, one last question. This is a little bit of an interesting question on it. What has been one of the most interesting examples of security compromise in which the LLM was the target of the attack? I think I can start with this, and then maybe Jacob, you can add some things. I think one thing I would say is that we've sort of realized working with our customers is just understanding the threat model is particularly difficult for our customers in this space. And what I mean by that is like when you go and buy a security product that you're sort of familiar with, like an endpoint security or firewall or something, it sort of have this like implied threat model. But if you're building an AI application or agent, the threat model is not as well understood. And why that's important is just thinking about like what protections do I need, and then kind of why I'm bringing it up in the context of this question is like where the LLM is the target of the attack. I think it's viewed more from my perspective as a means to an end. So we can't really discuss like the examples that we're familiar with our customers, but an example would be like a healthcare company that uses an LLM to access data. Like the LLM is the target of the attack, but really it's the means to elicit data through some record system that you're trying to that it's connected to, and that's really the target, more or less than the LLM itself. I think is one thing that I wanted to bring up. I don't know, Jacob, if that makes sense to you or you disagree with that,
Yeah,
or you have a better example.
I think that's right. In those types of examples, if it's like a data exfiltration kind of scenario, so this is what we're talking about, like MCPs and other types of risk. If your system has access to a lot of data, and an attacker wants to get the data out of it, how can they honestly get that out? So this is where we were talking before, like just restricting the access to something that user has is insufficient, because like in the like healthcare example you're talking about, like one thing, what if it's like medical transcription and someone can just orally describe something? If you gave it access to MCPs that can send email, maybe for um, generating a visit to a specialist or ordering a prescription. Well, and you also have it access to access the medical records, then it can generate an email with that context with the private data and send it to some third party just by saying something in the room because you have a medical prescription. Like that's a multi-stage attack chain where even it's doing what it's designed to do, but certainly not what you want. And so understanding that being a surface area of it could perform something as intended but not desired, and that each step of that is something you allow is a lot of risk. And so we've seen that kind of an example through a bunch of different things, through different chatbots that can perform different actions. And you put these together as attack chains. Does it have some way to get data out to someone that doesn't want? Does it have access to data that you need? And does it have access to third party? I think Simon Wilson coined that as the lethal trifecta. And we see that sort of everywhere as one of the biggest risks today, that you need to be able to lock down and assess whether your system is vulnerable to it.
Josh, anything to add before we finish up for the day?
I think Jacob captured it perfectly there with the lethal trifecta as a way to sort of put a punctuation mark on this conversation. But yeah, appreciate the conversation today, and get out there and secure AI, everyone.
Thank you, Josh. Thank you for your wisdom. Thank you, Jacob, as well. Again, RSA, we'll be at RSA coming up at the end of the month. So look for our threat report and look for our very exciting new product launch. Thank you very much. And I appreciate your time.